sign of a MEP 12A generator cranking over, the sight of the black smoke bellowing from the exhaust stacks, and the roar of the diesel engine can be a bit intimidating. It's music to the ears of civil engineer power production personnel. Operating this huge piece of equipment is quite a task. Making it produce electrical power takes the skill of a highly trained and proficient individual. With contingency deployments around the world on a steady rise, the Air Force requirement for reliable electrical power continues to increase at a rapid pace. The success of these deployments may very well be decided on civil engineers' ability to fulfill the electrical power requirements.
The purpose of this program is to introduce the MEP 12A generator set operation to civil engineer electrical power production personnel. This video will include pre-operational inspection procedures to prepare the unit for operation, single unit operational procedures, and post-operational inspection procedures to correct any deficiencies and perform required maintenance actions. The MEP 12A generator set operation program is divided into two separate videos. Personnel who have watched Part 1 should have a better understanding of the main components and their characteristics and the various gauges and controls.
As with any piece of Air Force equipment, a pre-operational inspection is the most important step. It should never be skipped. A pre-operational inspection should be thorough and should follow the technical order. The following covers each item that must be inspected. The MEP 12A generator set pre-operational inspection begins with a thorough walk-around visual inspection. It is imperative that the grounding of the generator be checked. All distribution cables should be inspected for nicks, burrs, and worn spots. Ensure the unit is free of any tools, rags, or spare parts that may have been laying around.
Don't forget to double-check the parking brake. Once the generator is operating, vibration may cause it to move. The engine crankcase sight glass, or dipstick, must be inspected for proper oil level. Also, check the oil filters, bypass filters, and the oil lines for leaks. Air intake filters need to be checked for proper airflow. These filters can be checked during engine operation using the service indicator scale on the filters. Batteries and cables are often overlooked during pre-operational inspections. Check to see if they need to be serviced. Low fluid level and loose or corroded cables cause most battery problems. Make sure the radiator is not leaking and verify the coolant is at the proper level. To accomplish this task, you must climb on top of the generator set. While you're up there, the exhaust system should also be checked for leakage and security. Don't overlook that rain cap. It must operate freely.
After carefully climbing back to the ground, open all the unit and radiator louvers. The access doors should remain closed unless access is required. The external fuel supply level needs to be checked. If you're in doubt on how long you can operate with the available fuel, call for a resupply. Place the fuel transfer switch in the auto position. Double-check the fuel selector switch to ensure it is positioned to the external fuel supply. Also verify the inline fuel shutoff control valve is in the open position. The handle should be parallel with the fuel line. The voltage regulator switch must also be turned to the auto position. Check the governor control module droop potentiometer to ensure it is set at 0 for single unit operation. Place the parallel or single unit operation switch in the single unit operation position. The load control and fuel pump circuit breakers are located in the control box. Place these breakers in the closed or on position. Move back to the main control panel and open it to gain access to the frequency mode selector switch. Select 50 or 60 cycle position, whichever is appropriate.
The power panel box is the next pre-operational inspection point. This part of the generator set is very dangerous. The TO warns that only qualified personnel should be working on high-voltage equipment. If other generators are operating and tied into the bus, death by electrocution can occur. Ensure the load break elbows are removed from the parking stands and secured to the proper output terminals. Also ensure the concentric ground wires of each high-voltage phase is properly connected to the ground stud located inside the panel box. Verify the maintenance lockout switch is in the operation position. Cranking this 12-cylinder diesel engine over is not an easy task. To accomplish this, connect the auxiliary power unit or a DC battery start cart to the slave receptacle. Depress the DC circuit breaker. Final pre-operational step is to perform the fault lights test. Push in the lamp test button. The alarm should sound and all the lights should turn on, with the exception of the battery charger indicator light. This has been quite a pre-operational inspection. The result of the time spent to accomplish this thorough inspection should produce many hours of trouble-free operation.
The pre-operational inspection prepares the MEP-12A for starting an operation. Since our pre-op was thorough, the generator should start and come online without any problems. Prior to starting, a quick last-minute walk-around check is required to ensure all personnel are clear of the generator. Those remaining in the immediate vicinity must have on their hearing protection. Place the engine control toggle switch in the start position to crank the engine. The engine will start and run at idle speed as long as the stop, run, start switch is held in the start position. Once the oil pressure gauge reads 25 to 80 psi, release the control toggle switch to the run position. The engine will accelerate to the frequency adjust rheostat setting. If frequency is not indicated or not at 60 cycles on the frequency meter, raise the frequency manually using the frequency adjusting knob until the desired frequency value is obtained. Check the voltmeter and adjust the voltage to the desired value. Place the synchroscope selector switch in the on position. Turn the breaker control switch to the closed position. The closed indicator light should energize immediately. This red indicator light signifies that the output of the generator is now being provided to the load terminals. Turn the synchroscope switch back to the off position.
With the engine running smoothly, disconnect the DC battery start cart from the slave receptacle. A recheck of the AC voltmeter and the frequency meter will indicate the electrical power being produced. The generator load will be shown on the watt meter. On an hourly basis, the generator set should be monitored for signs of possible malfunctions. The operator should check and record lubrication oil pressure and temperatures. Oil pressure readings should be between 25 to 80 psi. With the engine running normally at 1800 RPMs, check the oil level via the sight glass. Check the coolant temperature. Normal engine temperature should be approximately 160 to 185 degrees Fahrenheit. Observe and record this operational data on Air Force Form 1167 or an equivalent hourly log. If any undesirable changes occur, notify your supervisor immediately. The information and data gathered during your watch must be passed on to the relief operator. Uninterrupted power generation is a team effort. Take the time to do a thorough outbrief.
The operational procedures just covered are for normal environmental conditions. Section 2 of the technical order contains procedures for operating under the unusual conditions shown here. When the electrical power is available throughout the deployed location, everyone is happy. Unexpected power outages get a lot of people upset. When the generator set must be turned off, try to notify as many people as possible in advance.
As previously mentioned, the MEP-12A electrical power is fed directly to a primary or secondary distribution center. Load at these centers must be shut off first. Generator shutdown procedures may begin when there is less than 50 kW or no load on the unit. Turn the breaker control switch to the open or trip position. A green indicator light signifies that the main circuit breaker is open and the generator output power is not being provided to the load terminals. Allow the engine to cool down for approximately 5 minutes to 180 degrees Fahrenheit. Move the engine control toggle switch to the stop position. The engine will shut down. The last step is to pull out the DC circuit breaker on the main control panel.
The generator set pre-operational inspection is an important step prior to starting the generator. Just as important, post-operational inspection ensures that problems have been identified and corrected and maintenance requirements performed. These actions prepare the unit to go back in service. Before maintenance actions can begin, the maintenance lockout switch must be placed in the maintenance position. This prevents the unit from accidentally being started. Another precaution that should not be overlooked is the removal of the generator load cables from the output terminals. Place them on the parking stands. This action will prevent the possibility of any utility power being accidentally fed back into the generator set that you're working on.
The post-operational inspection should begin with a walk-around visual inspection. Primarily, the operator should check the security of items and look for signs of leakage and damage. One item typically overlooked is the exhaust system rain cap. Failure to ensure it closes could result in the muffler filling up with water and causing quite a mess when the engine is restarted. Specific items to be checked for leaks include the water conditioner filters and the oil and bypass filters. Don't forget to include the associated water hoses and oil lines. Verify the engine oil and radiator fluid levels and service as required. The fuel filters and strainers must also be checked. The fuel strainer elements may need to be cleaned more frequently than the TO recommends. Condition of the fuel being used will dictate this interval.
How often do these various filters need to be changed? Operators should refer to the Preventive Maintenance Checks and Service Interval table found in the technical order. This table includes items to be inspected and details the inspection procedures. It's always a good idea to check the fuel supply level once the generator has been shut down. Now would be a good time to schedule a resupply. The generator set should be returned to service or a standby mode as soon as possible. Operation of the MEP 12A generator set is one of the most important elements at bare base locations. Civil engineer electrical power production personnel have been key players in successful remote site operations. Without them, the site would come to a complete standstill.
This video was created to introduce the MEP 12A generator set to these technicians. It provided a detailed discussion on the procedures for performing a thorough and comprehensive pre-operational inspection. Once this was completed, the unit was started and the generator was placed in the operation mode. After shutdown, a post-operational inspection was performed to identify any potential problem areas, perform maintenance actions, and place the unit back in service.
To some people, the sound of aircraft taking off signifies the sound of freedom. On a deployment, the sound of the MEP 12A generator set signifies electrical power. When you don't hear that sound, you'll wish it was there.
For additional information on the MEP 12A generator set, refer to the program shown.